In the previous lecture, we were discussing method of reduction of order. Reduction of order. For a second order, this method is only valid for second order homogeneous differential equations. Let me add that. So you have to remember that this method works only for second order homogeneous and you can say linear ODE. So remember this. If we have a second order homogeneous linear ODE or in the standard form, I told you what is the standard form in the previous lecture. You can go back and see the previous lecture. What is the standard form of second order ODE? It is like y double dash plus p of x, y dash plus q of x, y equal to 0. So this is your ODE. And what is reduction of order method? Let me review it quickly. If we are known, if y1 of x is a known solution of equation 1, then we need to find second solution, say y2 of x, which is linearly independent, so that you can say that y1 and y2 are linearly independent, so that y1 of x and y2 of x are linearly independent. Why we seek another solution y2 of x of this equation if y1 of x is known? Because it's the second order differential equation, its general solution must contain two integration constants or two parameters. The solution of this differential equation should be a two parameter family of solutions. Okay. So we would need this method in while solving the higher order ODEs. So in this method, y1 is known and we need to find y2 so that y1 and y2 are linearly independent. So if we have two linearly independent solutions of this differential equation, of second order differential equation, then they form a fundamental set of solutions, and then we can write the general solution of this differential equation. So this is basically the purpose of this method. What this method actually does, we will use a transformation which will transform this second order differential equation into a first order differential equation. It will that transformation or this method basically convert or transform this differential equation, which is second order differential equation. It will convert in this equation into a first order differential equation, and then by solving that differential equation, we can find the second solution y2 of x. So now, how to proceed and how to find the second solution? First of all, we seek y2 while y1 is given or y1 is known, and these two are linearly independent solutions. If they are linearly independent, then we can say that their quotient is not a constant. We assume that their quotient is some function of u of x. I explained this thing in the previous lecture. Why this is so, you can see that lecture. Now, from here, we can write y2 of x is equal to u of x and y1 of x. Now, this is, you can say, equation 2, and this is the transformation which will transform this second order ODE into a first order ODE. Now, by inserting this transformation into equation 1, how we can insert this here, we need two derivatives of y2. So if y2 is this, y2 dash is what? We apply the product rule here. And we can write u y1 dash plus u dash y1. So it's a product rule. And y2 double dash of x is what? We have to apply a product rule on each term here. So it is u y1 dash plus u dash y1 dash. And plus, sorry, u y1 double dash plus u dash and y1 dash. Similarly here, u dash y1 dash plus u double dash y1. So this is basically the product rule. You can see that these two terms are identical. So we can write u y1 double dash plus 2u dash y1 dash plus u double dash y1. Now, inserting the value of y2 double dash, y2 dash, and y2 here in this equation, what do we get here? Let me add this person. Now, inserting those values into equation 1, what do we get? U y1 double dash plus 2u dash y1 dash plus u double dash y1 and plus p of x. The value of y dash is u y1 dash plus u dash y1 and plus q of x. Instead of y, we put here u. We are putting the value of y2 here. So we must have here u y1. So this should be equal to 0. Now, collecting the terms, this one and this one and this one. So we take common u from these terms and we can write u times y1 double dash, p of x, u common y1 dash, plus p of x, y1 dash, plus from this term, we take u common and we get q of x, y1 plus this term, u double dash y1, and then the remaining terms, this one, plus 2u dash y1 dash plus p of x and u dash y1. Yes. So this is equal to 0. Now we know that u1 is the solution of 1 as, sorry, y1 of x is solution of 1. What is 1? 1 is this equation. Now, if we put y is equal to 1 in this equation, if we put y is equal to y1, which is a solution of this differential equation, this equation will be satisfied. Means if you put y1 here, y1 here, y1 here, so this expression will be equal to 0. So kindly turn off. Yeah. Hello. Kindly mute your mic. Kindly mute your mic. Someone is talking. Group 10, maybe? No. So this whole term will become 0 because this y1 is a solution of 1. So this will be equal to 0. What we are left with, we have this u double dash y1 plus we can take common u dash from these two terms. So we can write here 2y1 dash plus p of x y1 times u dash equal to 0. Now this is our equation number 3. This one. Where y1 is known. You can see here that this is again a second order differential equation. Y1 is known. This is some known function. This is known function. This is known function. This is again y1 is known function. So we get this second order differential equation. We call it 3. Now in this equation, we assume that, or we let u dash is equal to w. We assume that u dash is equal to w. If we use this assumption or expression here, so u double dash will become y dash, because u dash is w, then what does it imply? U double dash is w dash. Then equation 3 can be written in this way. W dash or y1, yes, plus 2y1 dash plus p of x y1, p of x y1 plus, sorry, into w equal to 0. So this is equation 4. Now you can see that equation 4 is a linear first order differential equation. It is linear first order ODE. And this linear ODE can be solved by using separation of variables method, because only w is unknown here. Y1 is known, p of x is known. If y1 is known, we can compute y1 dash as well. So by separating the variables here, we can write y1 w dash is equal to negative 2y1 dash plus p of x y1 times w. So w को इधर divide कर दें, y1 को उधर divide कर दें. So what do we get here? 1 over w dw by dx is equal to y1 यहाँ पे divide करेंगे. So we get negative 2 y1 dash divided by y1 plus, sorry, minus y1 से divide करेंगे, y1 यहाँ पे cancel हो जाएगा. What do we get here? P of x. This one. Now, again, we can write this differential equation into this form. 1 over w dw is equal to negative 2y1 dash over y1 minus p of x whole dx. Now, the variables have been separated. We can now integrate on both sides. Integrating on both sides, what do we get here? Integral of 1 over w dw is equal to negative 2 integral of y1 dash over y1 dx minus integral of p of x dx. Okay. Plus a constant of integration, you can say it c1. Now, what would be the integration of this thing? It is natural log of w is equal to, यहाँ पे इसकी y1 का डेरिवेटिव ऊपर है, तो इसकी इंटीग्रेशन क्या होगी? negative 2 of log of y1 minus integral of p of x dx plus c1. So p of x is known. We can integrate this term as well. Now we can take this term on the other side, and let me use the next other board. This one. From there, we can write natural log of w plus नेचुरल लॉग ऑफ y1 2 यहाँ पे है, ये पावर में आ जाएगा, and then is equal to negative integral of p of x dx plus c1. Now again we can write here natural log of w into y1 square is equal to negative integral p of x dx plus c1. Now we have log here. If we remove the log from here, we can write w y1 square is equal to e raised power negative p of x dx plus c. Now we can separate here e power this and e power c. E power c1 को हमने you can say it c maybe c naught or c2 into e raised power negative integral p of x dx. W is here, w into y1 square. Y1 square can be divided on the other side here. We can divide it here, y1 square. Now this is the solution of that equation number 4, which is the linear first order differential equation. Now what is w? We assume that w is what? W is u dash. We need to find u here. So if w is u dash, then we can write u dash is equal to c2 e raised power negative integral p of x dx divided by y1 square. Now again integrating with respect to x here, integrating with respect to x here, what do we get here? U of x is equal to c2 integral e raised power negative integral p of x dx whole divided by y1 square dx plus another constant of integration c3. Now this is u of x. It is basically an unknown function which we wanted to find in the start. We assume that this transformation, हमने शुरू में, we assume that y2 of x is equal to what? It is u of x times y1 of x. We assume this. Now inserting the value of u here, we can have the y2, the second solution of that given second order differential equation, so that y1 and y2 are linearly independent solutions. If we have two linearly independent solutions, then they would definitely form a fundamental set of solutions of the given ODE, second order ODE, and then we can write the general solution. Now, while writing the general solution, how can we write that? We write the linear combination of two solutions, which would definitely have two parameters, two constants. So, we have to write those constants there. So here we have another two constants. Now, if we want to have a linearly independent solution y2, then these constants, we can choose them, choosing C2 is equal to 1 and C3 is equal to 0. We can write the final solution y2 in this form. So finally, y2 will be what? y1 of x times integral e raised power negative p of x dx divided by y1 of x whole square times dx. So this will be your second solution by using the method of reduction of order. Now, once we have y1 and y2, which are linearly independent, then the general solution, y1 and y2 are linearly independent. We can prove it, this thing as well. So I hope you can do it. If they are y1, y2 are linearly independent, then they form a fundamental set of solutions. In this case, the general solution, then the general solution of equation one, which is in standard form. So you have to write the given equation. If it is not in standard form, first you have to convert that given second order ODE into standard form, and then you can write these solutions. So the general solution in that case would be y is equal to C1 y1 of x plus C2 y2 of x. So this is how you can find the general solution of the given ODE if one solution is known, if y1 is known. I hope you understand it. If you have any question, you can ask me. Otherwise, I'm going to show you an example of this method. जी दानियाल।
सर जब हमने choosing C2 is equal to 1 and C3 is equal to 0 है, ये क्यों चूज किया था हमने इसका?
हाँ, क्यों चूज किया? It's a good question. देखें, आपके पास जो हमने solution लिखा ना यहाँ पे, these two things. यहाँ पे हमने इसको यहाँ पे हमारे पास जो solution आया u of x का जो expression आया उसमें C2 और C3 हैं, ठीक है? अब अगर हम ये u of x कितने solutions होंगे? Infinite many solutions होंगे, ना, ठीक है? y2 में u of x into y1 of x आ रहा है, y2 सेकेंड लीनियरली इंडिपेंडेंट सोल्यूशन होना चाहिए, ठीक है? अगर ये सेकेंड लीनियरली इंडिपेंडेंट सोल्यूशन है तो आपके पास यहाँ पे कांस्टेंट्स नहीं होने चाहिए. ये कांस्टेंट्स कब लिखेंगे हम? ये कांस्टेंट्स हम जनरल सोल्यूशन में लिखेंगे C1 एंड C2 की फॉर्म. अगर U में C2 और C3 रहते हैं तो आपके पास वो दो कांस्टेंट्स होंगे y2 के अंदर हिडन, और ये दो कांस्टेंट्स हो जाएंगे मजीद, तो चार कांस्टेंट्स हो जाएंगे. तो आपके पास जो सॉल्यूशन होगा वो क्या होगा? 4 पैरामीटर फैमिली ऑफ सॉल्यूशन होगा. लेकिन वी हैव ऑलरेडी डिस्कस्ड दैट सेकंड ऑर्डर डिफरेंशियल इक्वेशन का जो सॉल्यूशन है वो क्या होना चाहिए? 2 पैरामीटर फैमिली ऑफ सॉल्यूशन होना चाहिए, ठीक है? तो यहां पे हम जो u का एक्सप्रेशन है, instead of assuming C2 and C3 as parameters and they can take any value, in that case u of x would have infinite many solutions, or y2 would have infinite many expressions of the solutions. लेकिन we need only one. अच्छा, इसमें से infinite many solutions में से without constant solution क्या होगा? Independent of constants, ये वाला solution होगा, ये वाला, ठीक है? इसमें C2 को अगर हम 1 रख दें और C3 को 0 रख दें तो आपके पास ये जो सॉल्यूशन होगा, दिस सॉल्यूशन विल बी इंडिपेंडेंट ऑफ कांस्टेंट्स, इंडिपेंडेंट ऑफ पैरामीटर्स. ये आपके पास U2 का एक एक्सप्रेशन आएगा. C2 को इसलिए हमने यहाँ पे 1 रखा और C3 को 0 रखा, सो दैट आपके पास U2 का सिर्फ ये वाला सॉल्यूशन आ जाए, which we can insert here in order to get y2. अब आपके पास y2 जो है वो इंडिपेंडेंट ऑफ कांस्टेंट सॉल्यूशन है. y2 is a solution which is independent of parameters or constant of integration. ये दोनों क्या होंगे? लीनियरली इंडिपेंडेंट होंगे. Then while writing the general solution we can add here the constants, or you can say that even हम वो कांस्टेंट्स रहने भी दें और y2 को यहाँ पे हम उसी तरह लिख दें, तो आप after simplifying you would still get 2 constants. That would require some simplification. So that's why we are choosing there to make our life easier. We are choosing here C2 is equal to 1 and C3 is equal to 0. क्योंकि वही constants फिर हम यहाँ पे introduce कर देंगे in order to get 2 parameter family of solutions. I hope you get it. If you have any further concern, you can discuss
thank you
with
so
me.
much, Aki. Yeah.
Okay.
Thank
You
you.
can discuss with me. Okay, then let's do an example of this method, and then we shall move forward to the higher order ODEs. Now, example. Let me see if there is some example in my notes. which I have. Yeah. The function, y1 of x is equal to x square is a solution of the following ODE y x square y double dash minus 3x y dash plus 4y equal to 0. Find the general solution. Find the general solution of equation 1 of 1 on the interval 0 infinity. 0 infinity पे हमने solution find करना है so that के आपके जो solutions हैं वो इस पे valid हों. Now y1 is given, differential equation is given, we need to find y2 which is linearly independent of y1. Either you again assume that y2 of x is y1 of x times u of x. Here y1 of x is what? It is x square u of x. Now you have your transformation for y2. Now inserting y2 here in this equation and then solving, you would definitely get again that kind of second order differential equation which we obtained as the equation 3 on this board. You can see here of this kind. You would definitely get an equation, a second order ODE of this form, which is equation 3 here. And then further, you have to assume that u dash is equal to w and u double dash is equal to w dash, obviously. Now, you can convert or transform this differential equation into first order ODE of this form. And then following the same procedure, you can get y2. Or you can directly use the formula which we have derived here on this board. Or you can directly use this formula to find y2. Because y1 is known there in that example. Y1 is what? It is x square. You just put here x square. P of x, you need to find here. What is P of x? First, you need to convert this differential equation into standard form. Do you have any question, Zarnab?
Sir, we can't see the board.
Oh, sorry. Sorry. Now, either you follow the same procedure which we have followed there in that while deriving the method, or you can directly use this formula, in order to find y2. Because y1 is known here, we can find p of x, and then simplifying this integral, you can get directly y2. Now, what is p of x there? This equation is not in the standard form. First, you need to convert this equation into standard form by dividing both sides of this equation with the coefficient of y2 double dash. Because in the standard form, the coefficient of y double 2 should be 1. So we need to divide here by x square. So x square se divide kar dein. What do you get here? Minus 3 by x y dash plus 4 by x square y equal to 0. Now this is your equation in standard form. Now what is the value of p of x? We can see here the p of x is the coefficient of y dash. So p of x is negative 3 by x. Now, we have the value of y1 of x is x squared. We have the value of p of x. By inserting these values in that formula, which is y2 of x is equal to y1, which is x squared, integral of e raised power negative integral p of x. Negative p of x is minus 3 by x. So minus minus plus हो जाएगा यहाँ पे. We get this divided by y1 of x का square. So y1 of x is x square whole dx. This one. So you have to simplify this thing in order to get y2. Now, what is this? It is e raised power minus 3. Sorry, चलें इसको simplify कर लेते हैं. Let me simplify this thing for you. Here. So what was that thing? It is y2 of x is equal to x square. ये तो वैसे ही बाहर ही रहेगा. E raised power integral of 3 by x. E raised power integral of 3 by x is what? यहाँ पे integral of 3 by x dx divided by x power 4 dx. ये आ जाएगा. ठीक है. Now x square integral of e raised power 3x का integral क्या होगा? 3 बाहर आ जाएगा. So what do we get? It is 3 natural log of x divided by x power 4 dx. Now ये 3 इसकी पावर में जाएगा and e log cancel हो जाएगा, x cube आ गया यहाँ.
So minus 3 by x था.
जी?
So it was minus 3 by x.
There is one negative sign outside that integral as well. यहाँ पे भी negative है. तो negative positive हो जाएगा. ठीक है? So this thing, it is what? E raised power natural log of x cube. E log cancel हो जाएंगे. What do we get here? X cube. So we get x cube by x4 dx. And we get x square integral of 1 over x dx. And what do we get here? X square natural log of x. So this is your y2. While integrating here, मैंने कोई भी integration constant add नहीं किया. क्यों? क्योंकि ultimately we have to choose those constants. C2 is equal to, जैसे कि यहाँ पे वो previously हमने choose किया था. I have erased that thing. So while using this formula, if you add integration constants here, so you have to ultimately get the solution without constants. So this is your y2 of x. आपके पास ये y2 आ गया, y1 आपके पास, you have already y1 of x is x squared and y2 of x is x squared times natural log of x. Now, if you have two solutions, then you have to prove that these two solutions are linearly independent. How we can prove it? We need to find Wronskian of y1 and y2. I hope you know what is Wronskian, and you can find the Wronskian, and finally you can prove that these two solutions are linearly independent. Okay, यहाँ पे f1, f2, f1 dash and f2 double dash, f2 dash यहाँ पे find करेंगे, and you have to prove that this is not 0 for any value of x. ये solutions linearly independent होंगे, and then you can write finally the general solution. What would be the general solution in this case? Then the general solution of the given ODE is what? It is y of x, it is C1 times y1. Y1 is what? X squared plus C2 times y2. Y2 is what? X squared natural log of x. So this will be the general solution of the given ODE. I hope you get it. If you have any question, you can ask me. Remember that this method only works for second order linear homogeneous differential equation. Okay, if one solution is given, we can find the other linearly independent solution by reducing the order of that second order differential equation into a first order differential equation, and then we can find the general solution. I hope you get it. Now we are going to move for higher order ODEs. Now we are going to discuss higher order ODEs, homogeneous with constant coefficients only. Higher order ODEs with चलें पहले आप यहाँ पे it should be linear homogeneous with constant coefficients. So we are going to discuss now how to solve higher order ODEs which are linear as well as homogeneous, and the coefficients of the derivative terms, which are a1 of x, a2 of x, and so on, an of x, they are constants. So we can write that general nth order homogeneous linear ODE with constant coefficients in this way: an y nth dash plus an minus 1 yn minus 1th dash plus so on plus a2 y double dash plus a1 y dash plus a naught y is equal to 0. So this is your general nth order linear homogeneous ODE with constant coefficients. Now we are assuming that the coefficients here, an minus 1, a2, a1, an, a naught, these are constants, where you can write here an minus 1, so on, a2, a1, a naught are constants. Constants mean real numbers. Okay, now we are going to discuss how to solve these kind of differential equations. First of all, we need to know how to solve a second order. This one. First, we are going to discuss how to solve this differential equation, second order linear homogeneous differential equation with constant coefficients. Okay. We can write this equation in this form: a y double dash plus b y plus c b y dash plus c y is equal to 0. Now consider this to be equation 2 and this to be equation 1. Okay. In addition, if we want to write the initial value problem of general nth order, then we need to have initial condition along with this equation. Initial conditions kya honi chahiye? Y at x naught is, you can say y naught, y dash at x naught, you have y1, and so on. Yn, not yn here, yn minus 1th dash at x naught is equal to yn minus 1, where n minus 1, y1, y naught, these are constants. And this is the solution of that differential equation, and it's the value of solution at the starting point. So if we have a second order differential equation of the similar kind, how many initial conditions do we have here along with this differential equation in order to write the initial value problem? We must have two initial conditions: y at x naught, you can say it is y naught, and y dash at x naught is equal to y 1, where y0 and y1 are some constants. So this equation, along with these two initial conditions, this is basically what it is: second order initial value problem. So now we are going to discuss how to solve this initial value problem. Second order ODE, linear ODE, homogeneous ODE with constant coefficients, where A, B, C are real constants. Now, how to solve this? Let us consider first case 1. Case 1 में आप consider करें if you have a linear ODE. Linear अगर इसी में आपके पास इसी डिफरेंशियल इक्वेशन में आपके पास अगर सिर्फ फर्स्ट ऑर्डर ODE है तो आपके पास क्या होगा? You only have this equation. ठीक है, this is your linear first order homogeneous ODE with constant coefficients. We start with this one. It is a1 y dash plus a naught y equal to 0. Now this is what? This is first order linear ODE. Y dash, we can write it in this way: a naught by a1 y is equal to 0. So this is your. Now this is first order linear homogeneous ODE. And we know that if we have an equation of this form, dy by dx is equal to some constant times y. ये भी इसी टाइप की इक्वेशन है ना? ठीक है, we can write this equation in this form: dy by dx is equal to negative a naught by a1 times y, where this thing you can consider as a constant k. We have already seen that equation of this kind always have a solution of what? Y of x is what? C naught times e raised power kx. Any linear differential equation of this kind can have will have always a solution of this kind. ठीक है, ये तो general solution है. We can say that y of x is equal to e raised power kx is basically, where c naught is 1, is basically the form of the solution of this equation is always this thing. ठीक है, अगर हम यहाँ पे assume करें कि आपके पास ये इक्वेशन है तो इसका सॉल्यूशन किस फॉर्म का होगा? इसी फॉर्म का होगा. ठीक है, वी आर assuming that कि आपके पास if you have this equation, then the solution of this differential equation will be of this form: y of x is equal to e raised power some mx, where m की वैल्यू हमें नहीं पता. We are assuming that इस equation का solution इस type का होगा. Now, if this is the solution of the differential equation, we can insert the value of this y into that differential equation. By inserting this value into equation 1, you can say that this is 2. Substituting or inserting the value of y into equation 1, what do we get here? a1 times y1 dash. y1 dash is what? m times e raised power mx, plus a naught, value of y is e raised power mx. Okay. Now, by simplifying this thing, we can have e raised power mx कॉमन ले लें आप. अंदर क्या आ जाएगा? यहाँ पे a1m plus a naught equal to 0. ठीक है. Now, here we can say that this exponential function is never 0. E raised power mx is never 0 for any value of x because it's an exponential function. Now, if the product of these two factors is equal to 0, and we are saying that this factor cannot be 0 for any value of x, then obviously this factor must be 0. Then this implies that a1m plus a naught equal to 0. By solving this, what do we get? The value of m is negative a naught divided by a1. अगर हम इसको सॉल्व करें इस इक्वेशन को, तो आपके पास सॉल्यूशन क्या आएगा? y of x is equal to e raised power negative a naught over a1, सॉरी x यहाँ पे ये आएगा x है, सम कांस्टेंट टाइम्स, ये सॉल्यूशन होगा. अगर आप यहाँ पे if you look at this solution closely, what is this? It is basically what? E raised power C naught e raised power mx, where the value of m is what? This a naught over a1 negative. By solving this linear differential equation directly, you get this solution. Or we can solve the similar differential equation by assuming that the solution of this form, where m is unknown, we can find the value of m by inserting this solution into the differential equation. After inserting this solution into differential equation and solving it, we can find the value of m. And again, we have assumed that the solution is this. So m की value unknown है यहाँ पे. We can find the value of m, and then we can write finally the solution in this form. E raised power value of m is negative a naught over a1 times x. So this will be the solution of the given differential equation. We can write the general solution by multiplying this function with some constant c naught into minus a naught over a1 times x. So this is again the same solution which we have obtained by directly solving this. So the idea here is that the linear homogeneous differential equations, basically they have solutions of this kind. We can use the similar idea to solve the second order homogeneous differential equation as well. Now come to the second order IVP, initial value problem, which is basically second order linear homogeneous differential equation with constant coefficients. अगर आपके पास a y double dash plus b y dash plus c y equal to 0 है, by this equation is 1 again. We are assuming here, that y of x is what? E raised power mx is the solution of this differential equation. We are assuming again कि ये जो expression है, exponential function, ये इसका solution है. If this is the solution of this differential equation, we can insert this into this. अगर हम ये इसमें put करें, तो we need y dash. Y dash is what? M e raised power mx. Y double dash, ये क्या आ जाएगा? M square e raised power mx. Now, inserting the values y, y dash, and y double dash here, what do we get here? A times m square e raised power mx plus b m e raised power mx plus c e raised power mx equal to 0. E raised power mx आप common ले लें. What do we get here? am square plus bm plus c equal to 0. Now this thing is never 0. E raised power mx is not 0, because the product of these two factors, this factor and this factor, its product is equal to 0. One factor is not equal to 0. what does this imply? That this factor must be 0. So am square plus bm plus c equal to 0. This is a quadratic equation, polynomial equation, basically with unknown m. We need to find here, we need to find m here. If we have a quadratic equation, polynomial equation of degree 2, then how many values of m can we have here at maximum? If it is a polynomial of degree 2, then this equation must have 2 roots. M could have 2 roots. There is a question in the chat window. Yes. So quadratic, we know that quadratic polynomial equation has 2 roots. So m की 2 roots होंगी. We assume that एक root alpha है, एक root beta है. ठीक है? We are assuming that this polynomial equation of degree 2 has 2 roots, and those 2 roots are alpha, beta. If we have 2 roots, and we are assuming that this is the solution of this differential equation, we have 2 values of m, then how many solutions do we have here? We have 2 solutions. I hope you agree with me, because we are assuming here that this is the solution of this differential equation. And after solving, we get 2 values of m. m की 2 values होंगी, एक value के लिए एक solution, दूसरी value के लिए 2 solution. And we also know that a second order differential equation must have 2 linearly independent solutions in order to write a general solution. Because a second order differential equation must have a solution which is 2 parameter family of solution. It should contain 2 parameters, 2 constants, which are obviously the constant of integration. In previously we have discussed this. So the general solution of this differential equation must contain 2 parameters. So if we have 2 values of m here, we have 2 solutions. One for first value of m and the second for second value of m. Let's write it here. Let me erase the board first. Now, if we have 2 values of m is alpha and beta. So y1 of x will have e raised power alpha x, and y2 of x will be e raised power beta x, because m has 2 values. There is a question in the chat window, maybe. What is the question? Because the idea for solving linear differential equation, and what we get the general solution, we are basically generalizing that idea for the higher order ODEs in order to find the solution of higher order ODEs. This technique only works for homogeneous, linear ODEs, higher order ODEs, linear, homogeneous with constant coefficients. Okay, these 3 things you have to remember. This technique only works for homogeneous, higher order, linear differential equation with constant coefficients. This technique doesn't work for any other kind of differential equation. Okay, we are discussing it here only for the second order differential equation. Later on, after this, we will discuss this same technique for the differential equations of higher order. order 3, order 4, and so on. Now, these are two solutions now. So equation is second order. We must have at least at most two linear independent solution of that second order differential equation in order to write the general solution. Now, agar ye do solutions hai, these two solutions should form a fundamental set of solutions. For that, what we have to do, we have to prove that y1 and y2 are linearly independent. Linearly independent proof karne ke liye, what we have to do, we have to prove that Wronskian of these two things is non-zero for any value of x, for all values of x in the interval, given interval. If the Wronskian is non-zero, then these two solutions are linearly independent and they form fundamental set of solutions. If they form fundamental set of solutions, then we can write general solution of the given differential equation. Differential general solution will be what? Y of x, it is C1 times Y1 of x plus C2 times Y2 of x. Now, what is Y1? It is C1 e raised power alpha x plus C2 e raised power beta x. This will be the general solution of the given differential equation. Now, it depends what would be the values of alpha and beta. अगर आपके पास quadratic equation क्या आई थी? A m square plus b m plus c is equal to 0. And then we have assumed that alpha की दो roots हैं, m इस equation की दो roots हैं, m is equal to alpha and beta. ठीक है? And this equation is called auxiliary equation. Auxiliary equation corresponding to that given second order differential equation. अच्छा, अब it depends कि अल्फा बीटा क्या है. अल्फा बीटा दो distinct real numbers भी हो सकते हैं, अल्फा बीटा सेम भी हो सकते हैं, and what would be the third case? Alpha and beta, they can be complex numbers as well. But अगर आपके पास दो roots हैं, they could be complex conjugate of each other. तो यहाँ पे we can have three cases. अगर हम इसको quadratic equation को solve करें, तो आपके पास जो root होगी, it depends m की value क्या होगी? Minus b using quadratic formula plus minus square root of b square minus 4ac divided by 2a. Now, in a case 1, roots will be real and distinct if that case 1, roots will be real and distinct if b square minus 4ac is greater than 0. अगर आपके पास this thing which is inside this square root of sign b square minus 4ac, if this thing is positive greater than 0, then we must have two distinct and real roots. अगर आपके पास distinct and real roots हैं, in that case this will be your general solution. यहाँ पे अल्फा की वैल्यू आ जाएगी, यहाँ पे बीटा की वैल्यू आ जाएगी, दो different values हैं. For example, अगर आपके पास कोई equation है यहाँ पे और आपके रूट्स जो हैं वो एक आया है मे बी 2, दूसरा आया है 5, तो आपके पास सोल्यूशन क्या होगा यहाँ पे? c1 e raised power 2x plus c2 e raised power 5x. Roots will be different, distinct, real and distinct. Now, what in case 2, the roots could be real and repeated. In case 2, roots are real and रिपीटेड मीन्स अगर आपके पास बी स्क्वायर माइनस 4ac अगर ये 0 होगा तो आपके पास जो रूट्स होंगी वो अल्फा अल्फा रियल और रिपीट करेगी, क्योंकि आपके पास यहां पे इस एक्सप्रेशन में ये वाली चीज जो है, दिस थिंग इज 0. इफ दिस इज 0 यू कैन ओनली हैव वन रूट, b इज इक्वल टू m इज इक्वल टू माइनस b ओवर 2a. तो आपके पास अल्फा क्या होगा, माइनस b ओवर 2a, और यही दूसरी रूट भी होगी. इनफैक्ट आपके पास सिर्फ एक ही रूट होगी, ठीक है. तो इन दैट केस आपके पास जो सोल्यूशन होंगे y1 ऑफ x आपके पास क्या होगा, वो एक ही सोल्यूशन होगा, e रेज़ पावर अल्फा x, और you can say that e raised power minus b over 2a times x. You can have only one solution by using this technique. Second solution कैसे find करेंगे? Anyone? Because it's the second order differential equation and it must have two linearly independent solutions, then you can write the general solution. If you have only one solution, you cannot write the general solution for a second order differential equation. Now, by using this technique, you can only find one solution in this particular case. How can we find the second solution? Anyone? Fatma, Naveed, complex. No. If one solution is known, how can we find the second solution?
सर वो u of x वाली टेक्निक लगा के.
क्या नाम है उस टेक्निक का?
सर वो जो भी पहले की थी हमने, वो लीनियर होमोजेनस के साथ y1 of x is equal to u
क्या
of x
नाम
into
क्या है
y.
उसका? नाम क्या है उसका?
सर पता नहीं, नाम आपने लिखवाया नहीं है.
Any other?
Reduction of order.
Yes.
नहीं.
Yes. We can use the method of reduction of order. ठीक है? Thank you very much. I hope everyone get it. If one solution is known, this technique, if we have only one real root, if we have only one root for that particular auxiliary equation, ये auxiliary equation है, इसमें आपके पास if you have 0 here, you can have only one root and you can have only one solution here. अगर आपके पास one solution है, how can we find the second solution? We use, the answer is method of reduction of order. ये method of reduction of order मैंने आपको इसीलिए यहाँ पे हमने इसीलिए पढ़ा है यहाँ पे, so that we can use that method in order to find the general solution of second order ODE with constant coefficients in this particular case, where we can only have one real root of the given of that auxiliary equation. ठीक है? अगर एक solution हमें known होगा तो second solution हम method of reduction of order से calculate करेंगे. ठीक है? This is basically the case 2. Now, what is the case 3? Case 3 is what if the roots are complex? अगर आपके पास अल्फा और बीटा कॉम्प्लेक्स नंबर्स हैं, and I hope you know complex roots are always, they exist in pairs. ठीक है? And we call them complex conjugate of each other. Case 3, अगर आपके पास b square minus 4ac, if this is less than 0, ठीक है, complex case 3 में conjugate roots. अगर आपके पास सेकेंड ऑर्डर पोलिनोमियल है डिग्री 2 की और उसके दो रूट्स हैं, तो दोनों फिर क्या होंगे, कॉम्प्लेक्स कॉन्जुगेट ऑफ ईच अदर होंगे. इफ दिस थिंग इज लेस देन 0, तो आपके पास m जो होगा दैट वुड बी अल्फा प्लस आयोटा बीटा, and the second root will be alpha minus iota beta, or simply you can write alpha plus minus iota beta, क्योंकि ये complex conjugate होते हैं एक दूसरे के pairs में always exist करते हैं, ठीक है. This is the third case. In that case, the general solution can be simplified. Yeah, we can write the general solution in the similar way, but we will see that we can simplify that solution further into another form. Solution क्या होगा? यहाँ पे अल्फा बीटा हम लिख चुके हैं, यहाँ पे कुछ और लिख दें यार, चलें यही लिख दें अल्फा आयोटा बीटा अल्फा दिस. तो आपका सोल्यूशन क्या होगा? अल्फा प्लस आयोटा बीटा टाइम्स एक्स, ये पहली रूट, प्लस C2 e raised power alpha minus iota beta times x. This will be your general solution, but we will see later on in the next lecture how to simplify these terms in order to get more simplified solution. I hope you get it. These are three cases here while solving the second order initial value problem with linear, homogeneous, second order ODE with constant coefficients. ये तीन cases हैं. We'll discuss further these three cases in the next lecture. Now, if you have any question, you can ask me. Otherwise, we are going to stop here.